Okay, I don't know why this thing always starts up with the... Well, I'm trying to... The menu system's a bit weird on there. You've got to scroll it and all that. And I turn my phone the other way around after I've started. Otherwise, the text rolls off the bottom of the screen, which is a bit annoying. But, oh well, this is the trouble with the wide-angle, widescreen phones. Anyway, I'm waiting for the 3D filament to arrive, which should be probably tomorrow, or maybe today, I don't know, but it says Saturday. And I used up most of the filament. You can see the black on there. It's filament starting to run out, so I might have enough to do my coil former, which is what I really want to do, because I've been designing the coil former. So I'm going to be attempting to print that today. Hopefully there's enough plastic there to do it. I'll tell you why I run out of plastic in a minute. Just let me get it up on the screen a minute. Come on, catch up. Right. So I designed this coil former, and so I can wrap my wire around it, and this lid comes off. So I'll show you my edit group. Hide the lid. We'll just hide it so we can't see the lid, and I made it hollow so that so that I won't use as much plastic. And the other thing, excuse me, I've just woken up. I'm just half asleep. Even though it's midnight. Well, it's not midnight, it's nearly 3 AM now. So I've got 4 holes, one in each corner for the screws, and I made the 3 holes in the middle there, which will go on my adapter, this thing here, so I can just slot this on and put that on the reel to reel and wind the wire. So that's my adapter, and that's the reason for the 3 holes. I made a notch there so I would be able to orientate and tuck the wire when I start to wind it, so I can tuck the wire around the back of there. Let's see, let's get it round. So this little notch is just where I can tuck the wire in when I start winding it, so it doesn't pull away. And so that's that. So I'll just click on undo, then I can undo the hide. So the lid goes on top, then I'll put some screws in to hold the lid on while I wind it, and this just drops onto the adapter thing. So that's what I want to print, possibly later today. So I thought I'd show you that. Now in the meantime, I actually printed, I designed this third, I should say, of the drum, and the reason for that is that the printer's got some peculiarity, and I have not been able to figure it out because I've been in touch with technical support people on the open source community to try to understand why the things I print aren't perfectly round, because it doesn't make any sense. Because what's happening, if you get the ruler, if I get my ruler just to show you what I mean, the back of the bed, when I print something in a straight line along the back of the bed, it's 1 millimeter shorter from there to there than it is from here to here. Doesn't make sense, because you see the axis, this part here, this that rolls along this bar, right, it makes the same distance travelled. Sorry, it's because it's turned off, it's hard to move the head. So the printer head is running along the same bar, whether it's printed at the back, I can't move this because it's cold, or the front. So it just doesn't make sense. The only axis that's changing is the fact that this bed is at the back, at the front, sorry, when I'm printing along the back edge here, and that causes me some problems. And I have not, with things that are supposed to be round, because they come out slightly elliptical, very slightly elliptical, which is the reason why my drum, when I printed it, it's the reason why it's got this little, if you spin it, you see it's got this wobble on it. Hang on, if I spin it, it's got a wobble. So it's slightly bulged at one side more than the other. And now everything I print that's round, the bigger it is, the bigger the problem. Normally it's not a problem if it's a small item like a tiny thing. It's not a problem, but it's the bigger things, and I do intend to scale this up at some point. So what I've been doing is experimenting by printing something in a quarter section. The reason for doing that, which is this one here, I've hollowed it out a bit, and it's keyed like a Lego. So I've got these holes in the side, and I've got pins sticking out the other side. That's so that I can plug it all together. Then super glue, not super glue, but acetone with plastic, ABS slurry to make it really, really strong so it won't fly apart basically, and to hold it all together. So I'm going to be printing 3 of these, and because it's a third, it should circumvent that problem with the balance, with it wobbling. It should do away with that problem, because each one will be exactly the same. So when I print 3 of these, they'll all be exactly the same. So when I put them together, it should be perfect, well, near enough perfectly round, which is more than what it is when I'm printing the whole thing. Well, printing the whole wheel, this whole drum assembly, actually takes about 12 hours to print. But to print a quarter, and also printing each quarter, because it's a smaller piece, I can print each one in about 2.5 hours, because I've actually got these slots in as well. It saves some plastic as well, but these struts give me some strength on the rim. So by printing these thirds, not quarters, thirds, I keep saying quarters, you know what I mean, but it would make it possible to have 3 pieces exactly the same, so that when I plug them all together, I don't have any problems with it being out of balance. You see, that's the objective. So now I actually printed 2 of them out, and I'll show you them in a sec. The only problem with that is the fact that I run out of plastic, so I can't print the 3rd one, which I need. So I've got 2 of them in here, and I'll put them in the container so they wouldn't warp or anything. So here's 2 of them, and plug them together. Put them on the tip. It stinks of acetone in there because I put a bit of vapor in there just to keep them preserved so they don't split while I'm waiting for the plastic to print the 3rd one. So you can see they come out really well. They haven't really been acetoned, but I did put some acetone on this bit here where the when these come together, that'll be where the dry shaft goes through. So, and I also sprayed a little bit on the inside of here just to stop any warping and creeping, whatever. So these Lego pieces, these are the holes, and on the other side are the pins. I'll just plug them in like this together, if I can do it. Oops. But obviously once it's all acetoned and stuck together, it will be very, very strong, because if I can get this, it's plugged in, but it's just I've got to squeeze it in a bit with my I'm trying to do this with one hand. Actually, let me just get the camera stand a minute. It'll be a bit easier. Right, just put it on the camera stand a minute and show you what I mean. Sorry about this. Won't get in. Right. I'm not going to drop it all the way down. So, as I was saying, when I get all 3 pieces, you can't stick 2 together now and wait for the 3rd, because I won't be able to get the 3rd one in. You've got to push them all together all at once because it's locked together. So these will plug in like that, and now you can see I've got 2/3 of my drum, and of my new drum that I'm going to be printing. And once this is once I put ABS slurry in the crack, it will be permanent. It will be very strong. It'll actually be just as strong as if I'd printed the whole thing in one piece, because I've actually stuck things together before, and trust me, I can't get them apart again. They're that strong. Obviously it would need at least a week to dry out thoroughly to be extremely strong, but so once I get the third section, it's like a pie chart, isn't it? Looks like a pie chart. So that fits like that, because it's keyed in, because the Lego, oops, it's coming up, it wants to come apart. But once I put this together, I'll be acetoning in between all the cracks, and I'll put some elastic bands around it to hold it, oh shit, to hold it all together, right, to prevent it from coming apart. Now this will fit that way, it'll fit that way, and so you can imagine that the third piece will fit just the same. So they all fit like that, and then it's starting to, you can start to see my hub drive shaft part where they come together in the middle. You started to see it, but obviously when I get the third piece in there, it was a bit fiddly to splice this exactly right in SketchUp, which wasn't too difficult because it was 220 degrees, so 360 divided by 3 is 220, oh no, it's 120 degrees, so each section is 120 degrees of the full 360. So I just sliced it and just yeah, cut the piece off, the other two pieces off, and then I ended up with my third piece, which is what is going to form. It actually holds together pretty well when I push it like that. Almost, look at that, it's keyed in. Yeah, doesn't fall off if you get it right. So yeah, I thought I'd show you that. So obviously there's no stepping on it, not significant stepping on it. I can't really, nothing that I can't squeeze and put in a vise afterwards. So obviously I would put this in, once I got this together, I put elastic, I would wrap something really tight around the rim to hold it all together really tightly so that it sets and bonds together. So even pressure all the way around. Put elastic bands as well. Elastic bands, and I'd wrap some cord or something very tightly around several times to pull it all in really tight. Then I would stick this in a vise just to flatten it in this axis to make sure there's no steps, and yeah, something like that. And yeah, it's gonna work. Yeah, I've stuck things together before and they've never come apart. In fact, I've had a job, I've had to use a hacksaw to split them, so I know how strong this can be once you've acetoned and ABS plastic slurried it. Once it's got that slurry in between these gaps, you see what I'd do is I get my syringe, which is the plastic, this stuff, the plastic in a syringe. I would basically squirt it over the surface in the holes, right? Then I'll get some pure acetone, which is that stuff. Then I'll squirt some of that to dilute it a bit, so that when I press these things together, it squeezes out the surplus amount, and it would be bonded. Once it dries, it would bond it permanently, so it would never come apart again. And because I don't want this thing flying apart and hitting me in the face, obviously, once it's bonded, so once it's on a spinning line. So I would make sure it's really well stuck together. So yeah, it's a bit like woodworking, when you stick two pieces of wood together and you clamp it in a woodworking shop, same thing, but using plastic instead of wood glue. And once I've done that, I can get a plastic cover or something like the lid plastic cover that goes on the top like this. I could get something like that, print it, and then just put that on the bottom as an extra strength to make sure nothing ever flies apart like this, which wouldn't be perfectly round, but the main weight of it would be in these segments anyway, so that would give it a bit more reinforcement on the outside. So yeah, so I just wanted to show you that. Thought you'd be interested. So there's ways around it. The other advantage of this is because I printed it in a third. If I wanted to scale this up, make a really big, much bigger one, a larger diameter one, I could print a third of it, and then print 3 of them, and to make a larger diameter. So if you're limited by how big your printer bed is, there's ways of making this larger by simply printing it in a third and bonding it all together. You know what I mean? So there are solutions to it. To printing larger objects by splitting them. You can split stuff in SketchUp anyway, in there's a slicer program. You can actually split things with slicer as well, but I use SketchUp to do this. One. So I'll get my phone out of here again, which if I can get it out. Come on, you bugger. So I'm going to leave it in the container for now because it's got a bit of acetone vapor in there. It'll just stop it from shrinking, because I'm basically can't say the word. I'm keeping it in status at the moment. The word status, as in there's a bit of acetone vapor in, a small amount in there, this container, so it keeps that from shrinking too much. I don't want this thing to shrink before I get the third piece to go on, because if that happens, then I'm going to be having a problem with a step on the join. I don't want a step, so I want to keep it slightly swollen, a fraction. When I'm talking about slightly, I'm talking about probably 0.1 of a millimetre, something ridiculous like that, because I did put a little bit of acetone on it, but these things do tend to shrink a little bit when they get cold. I'm trying to get this on here. Get in there, you bugger. Right, pull this out. Right, so anyway, so that's it for now. Yeah, when I get some more updates, when I get that bobbin, when I get that coil wound, we can do a test with that. I've got to get that coil, I've got to get the former printed, and then I can wind it. So that's it for now. I'm going again. Bye for now.